Thank you, sir. Good evening to all of my friends and senior. Uh, Before I start, I would like to thank our OS team, especially Samantha sir and our Netra team, Dr. Mandal sir and Ekeda sir, who support to the activity that we are going to see today. Before we start, I would like to say that it's not a presentation, rather a story of trying to solve a problem that I face, especially as a pressure part engineer, while trying to carry out our job during overhauling as well as your major capital overhauling that we see in modifications. Uh, I'm basically from Delhi, which has two units of 800 megawatt boiler supplied by BHF, and it was commissioned in the year 2020 and 21, respectively. Now, we'll just check into the total number of joints that typically a boiler of VHL supply has. We have 250 megawatt, which has roughly 16,000 pressure part joints, and 500, 660, and 800 will have like 800 is having the highest, roughly around 49,000 to 50,000 we are seeing, and 660 around 38,000. Now, when we talk about the, say, boiler modification in such kind of boilers, which we have seen in, personally, we have carried out in 800 megawatt in Delhi, we saw around 11 to 12,000. During the short period of 60 days or 45 days, we have to carry out such kind of well joint, and again, that needs to be inspected by means of UT or RT. Now, during such kind of short duration, rigorous well defect identification, we see that tonight we have carried out 500 joints of RT by various departments, by various agencies, or say 200, 300. Now, in FQA person, say we employ three XPHL or who are qualified RT level 3. They need to inspect each of those joints, and we expect them to give by morning, like RT will be carried out till 3 o'clock, and then the site has to be left for the other pressure part to carry out the joint. Now we expect them to, inspect those 300, prepare those chemically processed those films, and then, come up with the your results so that we can take decision whether to cut the joint or, so this leads to a very humanly impossible task of, reducing the downtime of your units as well as give you confidence to carry out in those well joints, whether it is okay or we have to, cut it again and redo it. So this is the challenge that we face, and so I felt like why can't we use the image processing and AI for detecting the defects? So that's where we saw. Now we'll talk about the details, because overhauling is a part and parcel of our organization. And as we are running the power generation units, we also face BTL, boiler tube leakages. Now in NTPC to 24, 25, we have seen as of date 258 number of BTLs, and from our total 52 stations and 42 JVs. Considering suppose we have an approximate of 8 tube joints in each BTL, it's just an average, low average. We are seeing around roughly around 2,000 joints. Now, yet again, the delay in preparing the article chemically and then inspection, it takes roughly 45 to 1 hour. So we see around 2,000 hours have been lost just to prepare chemically and then inspect. So we can save this by using AI. I'm not saying that RT is the in the critical part of bringing your boiler into your the bar to bar, but we can when we talk about like increasing the efficiency of the boiler as a whole, we can address this by using AI. So now I already stated the problem. Let's see. Now the problem with the traditional way of art grading of testing is it's a gamma radiation. It's 360 radiation. It's a huge health hazard. You cannot carry out any other work when the radiation RT testing is being done. Now, and then the logistic issue, the low resolution, because in artificial minor cracks, your micro cracks, like lack of fusion and micro cracks, it will not be detected because of the sensitivity. And then again, as I talked earlier, the lead time required for this during this one. Now, we are in a state where we have to transition into AI. So, leaving aside the gamma radiation, we want to shift towards X-ray. Now, X-ray was discovered in 1912, and then immediately US adopted X-ray for detecting the bullets which were hit by a soldier, and with the help of X-ray, they could detect where the bullet is, they can open it. So now that's how we adopted X-ray into the field of medicine first. And now we have developed much in the field of X-ray, and that we are able to use it in the field of industry. So moving from gamma radiation to X-ray radiation will help to reduce your preparation time that use chemical जो हमारे वो कर रहा है उसको reduce कर देंगे. Now the solution which we are saying is radiography. Move towards digital radiography so that we get a digital form of data which can be used for AI interpretation. Now, in AI interpretation, what we did in Delhi was trying to solve this problem which I faced. We built an AI model using ResNet 50 by, we took the model which was built in ResNet 50, we extracted a feature using that, and then we have applied we applied our model, and we got 4 defects: lack of penetration, your double slat, and undercut cap. This model, when after training, we got that 95% accuracy it was giving our result. Now, your software that we developed is live. We have already, built a website where anybody can upload their X-ray image and check what are the defects in their uploaded file. So this will help us in long run to shift into your model where we are not relying on human interpretation of X-ray images, and will completely shift into AI. So that it will help us reduce the downtime. Now, the company which helped us achieving this one was a startup by a small group from IIT Kharagpur and a few from NIT Agartala. So while providing us this proof of concept software, they also moved ahead into building other softwares which they are providing for the defense in Badal, where they are providing checking the X-ray images of motor shell which are manufactured for our defense sector, so that they can identify the defects in those motor shell after being filled with TNT. And other projects that they are taking up is they are also trying to work up with the UT ultrasonic testing so that they can automatically detect and tell the defects scientifically. And while the whole project was personally sponsored, it basically cost me around 4 lakhs just for cloud computing, getting our data sets, and traveling costs and comfort. So it's cost effective. So when we talk about double wall images for our wallet tubes, we have to get large number of data sets which NTPC has. And after we get those data sets, we can again train our model so that all the 14 classification of defect can be addressed, and we can retrain our model. Because currently, with a very short amount of time and the resources that I had personally, we could train our model just for 4 defects. So in order to get all the 14 defects from our practical use, we'll be needing some kind of more resources. Thank you.